Energy is a word we hear all the time, in seemingly different contexts almost every single day. We hear about renewable energy on the news, and particularly in the winter, we hear people talking about their energy bills because they're worried about how much it's going to cost to heat their homes. So this brings about the question of what is energy, that we can talk about it so often and in seemingly such different ways. So in physics, we actually have a specific definition of what energy is, and you'll see it's really not that different from how we talk about energy day to day. Energy in physics is defined as the ability to do work. We can't talk about energy without talking about work, so we should probably define that right now, because work is another one of these words that we use an awful lot, but once again, physics has a specific definition for it. In physics, work is performed when you apply force over a distance. We can actually write this as an equation, W equals F times D, where W is work, F is force, and D is distance or displacement. If you've ever moved a box, a suitcase, or really any object in your room across the floor just to get out of your way, you performed work. You had to apply force to that box to move it whatever distance it took to get out of your way. If it was a short distance, you can see from the equation that that's going to be less work than if you have to move it across your entire room, down the hall, into another room. And in order to perform this work to move the box out of your way, you had to have energy available. That energy is enabling you to do the work because you're going to transfer the energy from yourself to that box in order to move it. So another way that we can think about work and energy is that the change in energy of the system, in this case, you and the box, is actually equal to the work done. When we define energy this way, it allows us to do a lot of interesting things. We've set up a way to measure and calculate energy, so it's actually a quantifiable property. Let's go back to the example of a box, and let's say that instead of just trying to move a box out of your way in your room, you're actually going to pack up everything in your room because you're going to move to a completely different house. And now you have 10 boxes to move. We can actually calculate the energy required to move all of those boxes. You might be saying to yourself, wait a minute, I'm now moving 10 boxes. That actually sounds kind of tiring. And if I'm getting tired, does that mean I'm actually losing energy? It turns out that energy is coming from somewhere, and in this case, it's going to come from food. So as you're moving these boxes, you may find yourself getting hungry. So you should probably grab a snack, something like, I don't know, an apple. Let's pretend that's what I've drawn there. So that you can get more energy to move the rest of those 10 boxes. And you might be thinking now, wait a minute, this energy coming from food to me seems different than energy between me and moving a box. And that's because you can actually see the box moving. Which brings us to our next point. Energy comes in various forms, and they don't all look the same. We have equations to quantify the energy of these various forms, and we'll talk about those in another video. But the key here is that energy can transfer between objects, and it can also convert between different forms, such as when you eat and get energy from that apple, and then you use that energy to move a box. So to summarize, energy is the ability to do work. Work is done when you apply force across a distance, and we can write that as an equation. And because we can calculate the energy of a system using equations, we now know that energy is a quantifiable property.